Here we're given the demand equation for a portable hairdryer. We're told that X is going to represent the quantity demanded per week, and P represents the unit price in dollars. In this problem, we are concerned about elasticity. So let's find our formula for elasticity. And we are given in the last problem there that it's negative P times the derivative of f of P divided by the original function f of P. Alright, that will be given to you on the test. Alright, so first of all, in order to do this, we need to remind ourselves that X represents f of P. So P is our independent variable, and we plug in P, and then out comes the quantity. So when we're finding our formula for elasticity, it's negative P. We're going to find the derivative of this function. One thing that we could do, and there's a couple different ways you can go about this, but to make it simpler, we could distribute in the 6. So that would be 225 divided by 6 minus 1/6 times P squared. So if I wanted to find the derivative of that, so the derivative of f of P here, well, this is just a constant, so that gives us 0. So we're going to use the power rule. So we're going to do 2 times 1/6. That gives me negative 2/6 times P. I'm going to reduce that power by 1. And I can reduce that. That's actually the same thing as 1/3. So negative 1/3 times P. So I'm going to insert that into my formula for that derivative. And then we're supposed to divide by the original function. So I'm going to go ahead and put in my 225 divided by 6 minus 1/6 times P squared. Now I want to make this look a little bit nicer. So there's a trick here to make this look a little bit nicer. First of all, let's multiply across the top here. We get positive 1/3, because a negative times a negative gives us a positive, and then P times P is P squared. So let's do that before we do anything else. And I notice that I have little fractions within my larger fraction. So I'm going to multiply by the LCD of all of those denominators within that fraction. So I have 3, and I have 6, and I have 6. So the LCD of each one of those would turn out to be 6. And I have to multiply everything on top and the bottom by the same value. So if I multiply by 6, and you can think about that as 6 over 1 if you want, I'm going to multiply that times every term in the top and the bottom of my function. Okay, so this is going to give me something a little bit nicer and a lot easier to work with as we go forward. So at the top we have one term, and we're going to simplify there. 3 goes into 6 twice. So now at the top I end up with 2 times P squared. So I don't have to worry about all those little fractions within the larger fraction when I'm typing this into our calculator. Here 6 divided by 6 gives me 1, so I end up with 225. And then here 6 and 6 also cancel, so I'm left with a negative P squared. I'm going to use this as my elasticity formula going forward. Alright, so I'm asked to find out, is the demand elastic or inelastic when the price is $8? So I'm going to plug in 8 in place of P in my formula there. Alright, I get 128 divided by 161 and end up with 0.795. Since this is less than 1, then I would say that the demand is inelastic. Alright. I want to know the same thing about $10. So we're going to plug 10 in place of P in our function for elasticity. And when I do that, I get 200 divided by 125, and that gives me about 1.6. Since this value is greater than 1, then we would say that the demand is elastic. Okay, so we're gonna just kind of put a couple of these in boxes so we know what we're talking about there. All right. When is the demand unitary? And remember that when the demand is unitary, we want to basically figure out what price is going to give me out a value of 1 from that elasticity formula. So I'm going to take my function for elasticity, and I'm going to take it as is with the p-value in there because I want to figure out what price causes this to equal 1. Okay, so I'm going to solve by doing cross multiplication. I'm going to think about this as 1 over 1. Then I'm going to cross multiply here. So I get 2p squared is equal to 225 minus p squared. I'm going to add or bring this term over to the other side, so I'm going to add p squared to both sides. So we'll end up with 3p squared is equal to 225. I'm going to divide both sides by 3. Okay, so we end up with p squared is equal to 75. Then I'm going to take the square root of both sides. Now, usually we think about plus or minus when we do square root, but since we can't have a negative price, I'm only going to consider the positive root of 75. So the price, we're going to round to the nearest 2 decimal places. So I put that into my calculator and I get $8.66. Okay, so remember when my demand is unitary, this is where I'm reaping the maximum revenue. So this is kind of our ideal price point to charge. Okay, and then lastly, we wanted to know if we lower the price slightly from $10, will the revenue increase or decrease? Well, in order to know that, we would have to know if the the demand here is elastic at $10 or inelastic at $10. So let's go back up to 10. So when the price was $10, the demand was elastic. So that means that changes in price are going to have a really pretty significant impact on change in demand. So I'm going to say that it's elastic. And if it's elastic, then a change in price, if I raise price, then the revenue will go down. Remember, they move in opposite directions when we're talking about elasticity. Which also means that if I lower the price, then the revenue will go up. So the answer here is that our revenue will increase if we lower the price. So that price is really sensitive when it comes to that demand. So if I change the price just a little bit up or down, then the demand will kind of be heavily affected. So lowering the price will actually cause the revenue to increase. Okay, for part D, if the unit price is increased slightly from $8, will the revenue increase or decrease? All right, so once again, in order to know that, we need to know if the demand at $8 was elastic or inelastic. So let's go back up to $8. So for $8, we determined that the demand was inelastic. So I'm going to put that here. So this means that changes in price doesn't really have that big of an impact on demand. Okay, so if you raise your price, the revenue will actually go up. So people are still going to buy. They're not going to care so much about the price being increased. So here our revenue increases. So raising your price will not have a negative impact. It will actually have a positive impact on the revenue.